Now we are going to study the universal law of gravitation, right? Why do we need to learn it? What is the purpose to learn this, right? तो आप लोगों ने मूवीज में देखा होगा there are two characters in Marvel movies that they can move anything with the power of their mind, right? So Professor X, right? आपने सुना होगा, देखा होगा, right? What do they do is that with the power of their mind they can do just do this and they can move any object, right? जो उनको दिखता है वो उसको वो हिला सकता है, ठीक है? So why cannot we do that? Why cannot we do that, right? Why? See, the thing is that we know that any two objects on earth exerting force on each other, right? Gravitation force on each other लगाते हैं, ठीक है? So why they are not affected by each other? Why do they do not get attracted towards each other or repelled by each other, right? Because we know that any two objects on earth exerts force on each other, right? अभी मान लो कि ये दो ऑब्जेक्ट्स हैं, right? And these are their centers, right? First of all, which is the factor that we are going to know that affects on their force, right? Let us consider the force that is exerted by two objects on each other as F force, right? Which is the first factor that affects the force is masses, right? The masses of these two objects. Let's consider the force of this object as capital M. This object mass, let's consider this as small m, right? So, right, how will the masses of two objects will affect the force, right? So the force of the two objects exerting on each other is proportional to the product of their masses, right? यानी कि कुछ इस तरह से, मतलब कि क्या होगा कि फोर्स जो है ये दो ऑब्जेक्ट्स एक दूसरे पे जो भी फोर्स लगाएंगे वो कितना होगा, इन दोनों के मासेस के प्रोडक्ट के जितना होगा, मतलब इन दोनों के मास जितना भी होगा 1 किलो 2 किलो, ठीक है, उन दोनों का हमें मल्टीप्लिकेशन करना है, ठीक है? जितना भी वो ज्यादा आएगा फोर्स भी उतना ही ज्यादा होगा, ठीक है? तो ये फोर्स लगता कहाँ पे है, ठीक है? This force is exerted by both of these along the line that connects the two center of the objects, right? So the force is exerted by both of these on the line that joins the two center of the objects, right? इस लाइन के जो है लाइन के ऊपर दोनों जो है फोर्स लगाएंगे, कितना, उन दोनों के मासेस के प्रोडक्ट जितना, ठीक है? जितना इन दोनों का मास ज्यादा होगा फोर्स भी उतना ही ज्यादा होगा. That is the first factor. Let's consider this equation as first, right? The second factor that affects upon the force, right? Distance, right? Let's talk about the distance, right? So the force that two objects exerted on each other is inversely proportional to the distance between them, right? तो सपोज कि ये दोनों जो हैं एक दूसरे से d distance पे, these two objects are at d distance from each other, right? So जैसे कि मैंने बताया force is inversely proportional to the square of distance between each other, यानी कि कुछ इस तरह, राइट? मतलब क्या हुआ कि इन दोनों ऑब्जेक्ट के बीच में जितना भी डिस्टेंस होगा, अगर डिस्टेंस ज्यादा है तो फोर्स उतना ही कम होगा, अगर डिस्टेंस कम है तो उतना ही फोर्स ज्यादा होगा, ठीक है? मतलब अगर इसका एग्जांपल दूं, मानो कि एक ऑब्जेक्ट आपके टीचर, दूसरा ऑब्जेक्ट आप खुद, जो भी बेंचेस पे आप बैठे हो, ठीक है। मानो कि फर्स्ट बेंच पे आप बैठे हो तो टीचर का आपके ऊपर फोर्स जो है वो ज़्यादा लगेगा। क्यों? डिस्टेंस कम है, जितना डिस्टेंस कम उतना फोर्स ज़्यादा। मानो कि अभी आप लास्ट बेंच पे बैठे हो, ठीक है, तो आप कुछ भी कर सकते हो, मतलब जो है कुछ भी कर सकते हो। मतलब क्या हुआ कि भाई डिस्टेंस जो है, अगर टीचर से आपका डिस्टेंस ज़्यादा है तो फोर्स जो है वो कम लगेगा, राइट। कुछ ऐसे ही, राइट। सपोज दैट दिस एज इक्वेशन 2, राइट। लेट्स रिकॉल इट। फोर्स कैसा होगा भाई? दोनों के मास के प्रोडक्ट जितना, दोनों के मास मतलब कि भाई कितना होगा, जितना मास होगा दोनों का उतना ही ज़्यादा फोर्स होगा, और डिस्टेंस जितना ज़्यादा होगा उतना ही फोर्स कम होगा, जितना डिस्टेंस कम होगा उतना फोर्स ज़्यादा होगा, इनवर्सली प्रोपोर्शनल। तो चलो देखते हैं कि भाई कितना जो है फोर्स हो सकता है, राइट। लेट्स कंबाइन दीज टू इक्वेशंस, राइट। हमें एग्जैक्ट चाहिए। ये तो क्या है, ये प्रोपोर्शनलिटी के साइन के हिसाब से, ठीक है। दीज आर प्रोपोर्शनल, राइट, मतलब जितना ज़्यादा उतना कम, ऐसा कुछ हमें यहाँ पे आंसर है। वी वॉन्ट द एग्जैक्ट आंसर ऑफ फोर्स, दैट हाउ विल इट बी, राइट। लेट्स सी। सो फर्स्ट वी विल, राइट। सो इन दोनों को अगर हम कंबाइन करें तो क्या होगा? कुछ ऐसा हम यहाँ करेंगे, राइट। Force is directly proportional to the masses of their objects and square inversely proportional to the square of their distance, right? अभी हमें कुछ मिला नहीं, ये तो हमने दोनों यहाँ पे दो जो इक्वेशन थे उनको कंबाइन किया। हमें एग्जैक्ट वैल्यू चाहिए। एग्जैक्ट वैल्यू के लिए हम क्या कर सकते हैं? प्रोपोर्शनलिटी की जो साइन है उसको हम यहाँ पे रिमूव करने जा रहे हैं। Whenever you remove the proportionality sign, you have to put equal to, right? Equal to and proportionality constant, right? Because here we are talking about the gravitation, we will put the proportionality constant as g, right? So F equals to the proportionality constant g, और बाकी जो भी है वैसे का वैसे, right? तो exact value of the force that are exerting by both objects on each other is equal to this, right? आप बोलोगे तो सर ये तीन चीजें तो हमें मालूम है कि भाई दोनों के मास कितने हैं और डिस्टेंस, जी की वैल्यू का क्या, ठीक है, जी की वैल्यू का क्या, राइट। तो जी की वैल्यू ही हम यहाँ पे फाइंड करने जा रहे हैं, राइट। तो जी की वैल्यू जो है, a scientist which was known as Henry Cavendish, he found the value of g with the help of sensitive balance। लेकिन उससे पहले इसको सॉल्व करना होगा, सिंपल मैथमेटिक्स है, नथिंग एल्स। अगर आपको g की वैल्यू चाहिए तो बाकी यहाँ पे जो भी वैल्यूज हैं उनको आपको क्या करना होगा? इक्वल टू के उस तरफ, राइट, अदर साइड ऑफ इक्वल। लेट्स डू दैट। यहाँ पे हम g की वैल्यू फाइंड आउट कर रहे हैं, राइट। सो दीज टू आर इन मल्टीप्लिकेशन, सो दे विल गो अदर साइड ऑफ इक्वल टू इन द डिनोमिनेटर, राइट। एंड बिकॉज दिस डिस्टेंस स्क्वायर, d square is in the denominator, so when it goes equal side, other side of the equal to, right, it will be in the multiplication, right. So by this equation he found out the value of g, right, which was 6.673 into 10 raised to minus 11 Newton into meter square per kg square, right. This is the value of proportionality constant g, right. This is the value of proportionality constant g, right. Now here, this one is the unit of proportionality constant, right? Here you can see how the value of G is as Newton, mass which is kg, and distance which is meter, right? So Newton into meter square or kg square, that is the unit of gravitational constant G, right? So that was the law of universal law of gravitation, right? It's a universal law of gravitation क्यों कहा जाता है? Because by this equation you can find out any two objects, either if it's on the earth or any side or any point of universe. If there are two objects at distance and masses, you can find out the force that is exerted on each other, right? So there is an assignment for you guys over here that by this one, because now you know the universal law of gravitation, there is an assignment for you. What is the assignment? That you will have to find out the force that is exerting between you and your friend sitting behind, sitting beside or behind you, कुछ भी हो सकता है, ठीक है? So कैसे करोगे आप फाइंड? आपको मासेस पता है, दोनों ऑब्जेक्ट, एक ऑब्जेक्ट आप हो गए, एक आपके पास बैठा हुआ आपका कोई भी फ्रेंड, दोनों का मास आपको पता होना चाहिए, जो कि हो सकता है, डिस्टेंस आपको पता है, राइट? एंड जी की वैल्यू को मैंने आपको यहाँ पे बता दिया, राइट? सो नाउ यू कैन फाइंड आउट द फोर्स दैट इज एक्सर्टेड बाय यू एंड योर फ्रेंड, राइट? दैट इज हाउ यू विल फाइंड आउट दैट व्हाई यू गाइस, if you guys are exerting force on each other, then why are you not getting attracted by each other and repelled by each other, right? So that is how you can find out the force, right? Okay, so what is the importance of learning universal law of gravitation, right? So by the help of this equation and this law, we can answer the unsolved questions, right? What are those questions? Are the revolution of moon around the earth, the revolution of other planets around the sun, right? The force that is exerted by earth on us, by which we are sitting or standing on the earth while it revolves, right? And the last thing which we can solve by the law of gravitation, universal law of gravitation, is tides, right? The motion of tides due to the gravitation of sun and moon, right? So that is the importance of gravitation law, right? Universal law of gravitation. Okay, so now we are going to learn about free fall, right? What is a free fall? As a naughty child, we have done it many times, right? What? We have thrown a ball or a heavy object from a height, from a building, right? When that object, that ball comes straight towards the land, that ball is called a freely falling body, and the motion of it is called free fall. So our today's topic is free fall, right? How we will do that? Take an object or a ball, throw it upwards, right? What will happen? It will go at certain height and come eventually towards the land. Have you ever wondered that when it comes towards the land, with what acceleration will it come towards? That particular thing is we are going to do today, right? Let's see. So when that particular object is coming towards the land, have you ever wondered with what acceleration, or is there any velocity involved in it? Let's do that. Let's check that. So consider that this is that ball which is you throw from a height, right? So we are checking over here if there is any velocity, change in velocity involved or not, right? Tell me that if the ball will come towards the land straight, or will it go like this? Obviously it will go straight to the land, right? So there is no change in direction, right? वो अपनी direction change नहीं करेगा, right? So because of change in direction, there is no change in velocity, right? But It is coming towards the land because of gravitational force of the earth. We know that, right? And when an object is coming towards the earth with only force, which is gravitational force, there is change in velocity, right? Change in velocity is involved, right? तो अगर change in velocity involved है, then we know then motion of the object is accelerating, right? Acceleration होता है, right? So we know that it is accelerating towards the land, right? What is the unit of acceleration? It is meter per second square, right? So here, because the acceleration is due to the gravitation of earth, right? Gravitation force of earth. Acceleration here, we will not denote that as A. We will denote that as small g. Unit of that acceleration will also be meter per second square, right? So meter per second square, right? Now we are going to find out that with what acceleration will it come to the land, right? To find out that, we have to know that with what force it will come down. So we have already done that with what force the two objects exerts on each other, right? We know that second law of motion. What is the second law of motion? That the force, right? Force is the product of mass and acceleration, right? Mass and acceleration, right? Because here we are denoting acceleration as g, it becomes, right? So now, because we are going to find out that with what force it will come down, we know that with what force the two objects exerts on each other, right? The universal law, right? The universal law of gravitation, right? Remember what was it? F equals to the gravitation constant, mass of both the objects. Here the capital M is the mass of earth and the small m, okay, not g. Small m is the mass of whatever the substance was, whatever the object was, and d square, right? The distance between those two, right? Okay. So because the force over here, right? Force is taken as mg, which is mass of that object, and g, which is the acceleration due to the gravitation, right? So let's put it over here. Right, so it becomes this one, right? You can see over here that this and this, both of these are same thing, right? This is the mass of the object and this is also the mass of object, so this crosses out, right? So what becomes our that becomes our main equation, right? What does this, what is the meaning of this? Is that the gravitation, the acceleration due to the gravitation of earth will be equal to the mass of the earth, the constant, gravitation constant, and will be inversely proportional to the distance of between those two objects. By this equation, we can find out the acceleration of an object that is coming far from earth, right? Far from the surface of the earth, right? Okay. Now what about the object that is near to the surface or onto the surface of earth? I am talking about any object. Suppose this is earth, right? And the object is over here or over here, near to the surface of the earth and onto the surface of the earth. We know that the surface of the earth or the distance, right, which we call the radius, right, is not equal at every position, right, because the earth is not total sphere, right, so it varies from each other. So whenever we are taking the distance between two objects, earth and the object, we will take that as r, right, which is called the radius, right. So here, because the distance is r, our equation becomes this one, right. So when an object is at near to the surface of earth and onto the surface of earth, with what acceleration it will come down, we can find out with this one. And if any object that is far from the surface of the earth, we can find out with this equation, right. So that was